morning, class. How are you today? Oh, I see you're so happy to be here. I love your smiles, by the way. Thank you. You keep those smiles. By the way, I miss you guys very much. So today I thought I'd get you guys to get ready for next week's test. As you know, you have a test on logarithms next week, right? So today we're going to review all of the properties and laws of logarithms. Ready? Ready? Andrew, wake up. Over here, buddy. Okay, good job. Way to go, Andrew. Here we go. So he's ready now. By the way, Christian, thank you for being here on time today. I like that. Good job. I appreciate you very much. Okay, Julia, stop paying attention to honesty. Here we go. So we're going to now focus on the properties of logs. So here we go. The properties of logs are when you add, what will happen? Yes, that's right, Emmanuel. You multiply. Good job. And when this multiplication, it turns into, yes, it goes into addition. Thank you, Emmanuel. How about when you have division? What will you do with division? Division turns into subtraction of logs. That is correct. Way to go, David. Good job. How about the power rule? What happens to an n that is an exponent? Well, it goes over to the front here. Way to go, Victoria. Good answer. Good answer. Good job. Okay, Brian. Ready, ready, ready? Here we go. This is what you're going to have to do. So everybody stand up. Thank you. Thank you. Now that you're all standing, we're going to go over this. So tell me, what do you do with one log? Yeah, you rotate. Ready? 3 times. Yeah, you rotate. What do you do with one log? You rotate. What do you do with one log? You rotate. Good job. So now we're going to see, what do you do with more than one log? 2, 3, 10. What do? You condense. Way to go, Abraham. Yes, you condense. 2, 3 times. Ready? And you condense. Yes. Kayla, what happens when you have 2 equal logs? That's a cheerleader move right there, baby. Come on now. Yes, that's right. When you have 2 equal logs, you cancel. Ready? 1, 2, and 3. We're going to do it 3 times. What do you do with 2 equal logs? Yes, you cancel. What do you do with 2 equal logs? Yes, you cancel. Katie, what do you do with 2 equal logs? Yes, you cancel. Way to go. How about you, Nancy? Do you know what it means to, what was it I was going to do? Darn it. Condense. Oh, to expand. Thank you, Nancy. Oh, you read my mind. Thank you, sweetheart. So what does it mean to expand? Well, expanding is the opposite of condensing. So instead of condensing, you expand them into many, many logs, okay? So now, we know the logs, we know the properties, now we know what to do with them. So what you gotta do is you gotta go up into my YouTubes and you gotta take a look at the examples and prepare yourselves. By the way, I appreciate all your smiles. You've never smiled at me so much. In fact, you never even blinked. I must have been really good today. So thank you and have a good day. You rotate. Ready? 3 times. Yeah, you rotate. What do you do with one log? You rotate. What do you do with one log? You rotate. Good job. Yes, you condense. 2, 3 times. Ready? And you condense. That's right. When you have 2 equal logs, you cancel. Ready? 1, 2, and 3. We're going to do it 3 times. What do you do with 2 equal logs? Yes, you cancel. What do you do with 2 equal logs? Yes, you cancel. Good morning, everyone. Today, we are going to focus on the exponential logarithmic equations letter B. So the examples that I'm about to do for you today are all coming from exponentials logarithmic equations letter B. So after going to all of letter B, you'll be able to go back and finish up letter A. And then following that, you're going to be working on the review sessions that are right at the end of the packet so you can get ready for next week's test. Yes, I did say next week's test. That means next week you have a test for logs. I will give you the date and the time that you will have to do this test and then instructions as to how to submit it. But before we talk about the test, let's finish up this last lesson on logarithms. And let me first remind you of the lesson itself that we're going to be covering and what we've already covered. So here are your 4 reminders. Remember that when you have one log, you're always going to rotate and then you're going to turn it into an exponential. And if you can simplify it, you're going to simplify it. That's number 1. The second one here is that whenever you have more than one log, be it 2, 3, 4, 5, 6, you're going to condense them into one log and then you're going to simplify it if possible. When you have 2 equal logs, you're going to see this today. That means you have now an equation, whereas before you didn't necessarily have an equation. Now you will. Whenever you have 2 equal logs, one on the right and one on the left, and they have the same base, then you'll be able to cancel them. and then you'll be able to solve. Now remember that when you solve them, you're going to get some answers, and you need to go back and check them into the original to make sure that your logs are positive. Once again, logs cannot be 0 and logs cannot be negative. So anything related to the log cannot be 0, cannot be negative. Finally, I'll remind you again, to expand means to put it into many, many logs, and that we won't be doing today, but we've done in the past. Okay, if you'll follow along, we will begin with equations letter B. So here is number 1. As you've done before when we did exponents, we need to make sure that this equation here is what is called a one-to-one equation. In other words, I need either the bases to be the same so I can cancel, or I need the exponents to be the same so I can cancel. In this case, I'm going to take a look at the relationship between 6 and 36, and I'm going to notice that 36 is 6 squared. Therefore, giving me common basis, which means that they cancel. 2x is equal to 2, therefore x is equal to 1. Okay? Now that was the easy one. Of course, they're going to get a little bit more challenging. Here's one with a fraction, right? Once again, you're going to need to change this into a one-to-one equation so you can cancel something out, usually the basis. I'm going to leave 3 to the x alone because you can't do anything with that. And I'm going to notice that this here is 3 to the third. But when you move it up and you make it unhappy, you're going to end up with 3 to the negative 3 because you move it from the denominator up to the numerator, which then gives you common basis again, so x is equal to negative 3. Okay, that was 1 and 2. Let's do a few more of these before we head over to equations of logs. And of course, we're doing this because we're going to need it when we do the equations in a few minutes. Once again, I'm looking for a common base between 3 and 81. And since I cannot change 3, I know that I have to leave that guy alone. But wait, I know that this is 3 to the fourth. Yet again, the bases cancel because they are the same. You end up with 2x is equal to 4. So in this case, x is equal to 2. Okay. Number 4. Now remember, if I'm going too fast, you can always rewind this and go slower. Or if I'm going too slow, you can speed it up and go faster, of course. Now I need a common base between 8 and 16. And you're going to say, well, 8, because that guy has 8. No, but 16 cannot be written as an exponential of 8. So therefore, I have to find a different one. And what it is this is 2 to the 3 to the x. Okay? This is 2 to the 4 to the 4x minus 1. See, now I have a common base of 2. And so now, if you take a look at these two, I'm going to use the power rule, which says thou shalt multiply. So this is 2 to the 3x is equal to 2. When you distribute here and here, you get 16x minus 4. Now that I have my common basis, I can set this equation up and say, let's see, 3x is equal to 16x minus 4. I can move the 4 over this way and subtract the 3, which will give me now minus 3 is 13x. So what will I get for this one? An ugly looking fraction, and because I know you guys don't like fractions, but it's still beautiful. Check that out, 14 over 3. And that's number 4. Okay. Number 5, I'm going to give myself a little bit more space here. And I'm going to look for a common base again between 4 and 8. No, I cannot change 4 into 8. And I cannot change 8 into 4. But I can use this again as 2 to the third power. 4 plus 3x. And I can change this. Again, this is 2 squared. But when you make it up unhappy, it becomes 2 to the negative 2. Once again, I'm going to use the power rule here. And I'm going to end up with 2 to the 12 plus 9x is equal to 2 to the negative 2. Again, why? Because I distribute, right? There they are. That's what I was looking for. Yep, they go away, and therefore 9x plus 12, that guy is equal to negative 2. When I move the 12 over to the other side, I will get 9x is equal to plus 12 will give me 10. And so therefore x is equal to another wonderful fraction, 10 over 9. That is 5. Couple more of these. 6. I need a common base between 4 and 32. Yet again, this is 2 squared. But when I move it up, this is 2 to the negative 2 to the y power. This is 2 to the 5th. 32 is to the y plus 1. When I use the power rule on both sides, I will end up with 2 to the negative 2y is equal to 2 to the 5y plus 5. Well, look at here. I have my common bases, and now I can solve for y. In other words, negative 2y is equal to 5y plus 5. To which, when I add the 2y, I will end up with 7y. When I move the 5 over to the other side, I will get negative 5. And finally, when I solve for y by dividing by 7, I get negative 5 over 7 is equal to y. That's number 6. Okay? Number 7. I'm going to have another fraction here. And so I'm going to remind you that this, when I move it up, is 5 to the negative 1. This is 5 to the third. 125 is to the x plus 1. After doing so many of these, now you're going to become an expert. This is 5 to the negative 1 is equal to 5 to the 3x plus 3, yet again when you distribute, right? Let me see. Common bases. Whoopee, that's what I was looking for. So when I subtract 3, you get negative 4 is equal to 3x. So therefore, x is equal to negative 4 over 3. Okay. One more, number 8 here, that has a fraction on it. And what you're going to see is that there is absolutely nothing you can do with 2/3. However, this here over here is 3/2 squared. You see, 3 squared is 9 and 2 squared is 4. But this is 2/3. This is 3/2. That's not the same. But if I put a negative exponent, that'll mean these guys will switch around. In other words, 2/3 to the x is equal to 2/3 to the negative 2. You switch these around and you change the exponent to a negative. In other words, you essentially make it unhappy. What this will do is it'll allow you to have common bases which you can cancel, and therefore x is equal to negative 2. And finally, we get to something that doesn't have a common base. So now, it's about time we use the calculator. There is no common base between 5 and 75. And I know what you're thinking. 5 goes into 75 15 times. Yeah, but that's multiplication. I need exponential. So there isn't any. So what you're going to do is you're going to introduce either the common log, log, or the natural log, ln, whatever you like. They both work. I dare you to try both of them and use the calculator. You're going to see that you get the same answer. In other words, you're going to introduce the word log on both sides. This is why we need logs. So if I put the word log here and log here, you're now going to remember that this is a power. And where do powers go? In the front. So n log 5 is equal to log of 75. If I was solving for n, that is multiplication, and the opposite of multiplication is division. So you divide both sides by log 5, and you will get your n to be this. Now, you can use the calculator to give me the decimal answer, or you can write it as log base 5 of 75. Sometimes they want you to put it in logarithmic form. There it is. Other times they want you to get the decimal equivalence of it, which means it's time to use the calculator. You already know where the word log is. It's right up here. The button, right? Log. And then ln is right below it. For those of you that wanted to try ln to see if you got the same answer, you would have had the same answer. So I'm going to say the bully rule, log of 75 divided by the log of 5, which of course is called the change of base rule. So log of 75, close the parentheses, divided by the log of 5, close the parentheses, enter. And therefore, you end up with an answer of 2.68. Let me see, round it off to a 2. Nope, it stays that way. And there you are to 2 decimal places, okay? This is why logs are important. Now let me show you something. I'm going to go to the calculator and I'm going to say 5 to the power of 2.68. And you're going to see that it's going to be something very close to 75. So 5 to the power of 2.68. Now remember, this is an approximation, so you're not going to be exactly 75, but it will be close. Enter. What did I get? I got 74.686, something really, really close. Had I used more digits, I would have gotten closer to 75. Okay, push that aside. Let's do another one of those guys here. And again, there is no common base between 1 and 5. However, I don't have to introduce logs for this one because this is 5 to the 0 is equal to 5 to the 2x minus 3. A little bit of trickery there, huh? That's because anything to the 0 power is always 1. So therefore, if you see a 1, you might be able to use this shortcut here. Cancel your bases. 0 is equal to 2x minus 3. Move the 3 over, that's 2x, and so x is equal to 3 over 2. Had you used log, you would have seen that your calculator would have said 1.5, which is what 3 over 2 is. One more, and then we would have finished all of the left-hand side, and then I'll give you your commercial break, and you can go out and get a snack or something, do some exercise, and then we're going to go over all the ones on the right-hand side, okay? Here's our last one, and it's a very easy one. Now, this is e, the exponential. If you want to know where the e button is on the calculator, it is right underneath ln, which means you have to press the second function button. But in this case, you don't have to because I have common bases, so I will cancel in a minute. I will also say that the opposite operation of e is ln. That's why these are inverse operations on the same key button on the calculator. So if you wanted to introduce ln on both sides and cancel them, that would be perfectly fine. But I'm not going to. I'm just going to cancel the common bases and end up with 2x plus 6 is equal to x plus 4. When you move the x over to the left, you end up with x. When you subtract 6, you get negative 2. And that's how easy this is. Okay? We'll be right back in a few minutes, and we're going to go over the ones on the right-hand side. Commercial break. Well, all right, let's continue now with number 13. Here's that famous e I was talking to you about, the exponential. And therefore, now we're going to need to solve for x. Now, you might be noticing that there are two variables here, e and x, and thinking, my teacher taught me that I could not solve one equation when there's two unknowns. But remember that e is an exponential, like pi. If you wanted to know the value of e, all you do is you go over and you go second function e, there's your e, to the 1 power. And then you press enter and you're going to see the famous number of 2.718281828 and goes on forever and ever and ever, just like pi did. Okay, I also told you a few minutes ago that the opposite or inverse operation of e is ln. Think about it this way. We have mainly two types of students that come into Pioneer High School, right? We have the Edwards kids and we have the Los Nietos kids. That makes up almost 90% of our students at Pioneer High School, correct? Therefore, how do you get rid of Los Nietos students? Well, you put them right next to an Edwards students and then they fight and then we suspend them for a day. Yay! No, that's not nice. So let me cancel that. However, what I'm trying to say is that if you ever want to get rid of an E, Edwards, you put an LN, Los Nietos, right next to it and boom, they cancel each other out. So the opposite or inverse operation of E is LN. The opposite or inverse operation of LN is E. But remember that e has to always be written as an exponent, okay? Because it's called the exponential. Okay, having said that, let's go try to get rid of the e. How do we get rid of the e, Edwards? Well, let me introduce a Los Nietos student. And now they are inverse operations and they go away. 2x is equal to ln of 5, okay? So ln of 5. And if I wanted to solve for x, I simply divide by 2, and cancel, and I would get my x answer. How do you do this, you ask? You simply go over to ln of 5, close the parentheses, and then divide by 2. And when you divide by 2 and you press enter, you're going to get to 2 decimal places, 0.80. And there you are. If you were to go back and put e to the 2 times 0.80, you would get 5. Okay, that is the exponential. Let's try it again with another e here until we get the hang of this e business, right? Okay, here's one more e. I need the e by itself here. That means I gotta get rid of this 5 that's in my way. So let me get rid of it by simply dividing by 5, and now it's gone. So now I have 3/5 is equal to e to the 1 minus 4x. And how do I get rid of the e? Yes, you ln it, and these guys go away. So now I got ln of 3/5 is equal to 1 minus 4x. If you just do the math, as normally you would, this is the ln of 3/5 on the calculator minus 1 is equal to 4x. Negative 4x. The final step will be for you to divide everything by negative 4, and then you'll get x. And now you go to your calculator. So you have to be careful. Don't forget to close that parentheses, okay? So I'm going to write ln of 3 divided by 5, close the parentheses, minus 1. And then I'm going to enter that so I can get my first value. And then I'm going to divide by negative 4. Divide by negative 4. Remember that negative is down here at the bottom of the calculator, okay? Dividing by negative 4, enter, and you're going to end up to the nearest hundredth, 0.3777, which is 0.38, because you have to round up, okay? And that's how you do exponentials, okay? All right, so now we're going to move on to logs and log equations. And so here is the first of logs. And what we went over last week were the properties of logs, which basically stated that whenever you have a common base of a log and the base of the exponential, that they cancel out. So here, the base of the exponential, because this is an exponential expression, and the base of the log are both the same. Hey, they cancel out, leaving you 12 minus x is equal to 9. And then you just solve this, right? I'm going to move, let's say, the x over to this side and the 9 over to that side. So 12 minus 9 is 3 is equal to x. And that's that. Okay? Number 16, however, you might say, hey, I'm going to do the same thing, and I'm going to cancel the base of the exponential and the base of the log. However, you can't because there's this 2 in my way. But I now remember the power rule that said that whenever there's a number in the front, it really is a power. It needs to go here. So let me rewrite this. 5 to the log base 5 of 7 squared is equal to 5. Oops, that's not a 5, by the way. If you take a look at your worksheet, it is a letter S. Otherwise, I wouldn't have a variable, which is the reason why we hardly ever use the variable S, because it looks like a 5. All right, so let me be careful to make sure and make it all nice and round, huh? Now you were going to notice that the base of the log and the base of the exponential are the same. So 7 squared is equal to S. Therefore, 49 is equal to S. And we're done. Okay, more logs. Number 17. Finally, we have logs. Okay, so now when we have logs, this is an equation here. And so therefore, we have to cancel. But you cannot cancel one log against 2. Think of a fight. One log is fighting 2 logs over here. Is that a fair fight? No, it's not 1-to-1. Therefore, you must make it 1-to-1 before you cancel. So let me look on the left-hand side and let me ask you, what do you do with 2 logs? That's right. You condense them into 1. So let me go back and rewrite this as log base 5 of 2 over 8. Why 2 over 8? Because this is a minus. And when you subtract based on the properties of log, it means that you divide. Is equal to log base 5 of t. Now, do I have two equal logs? Log base 5, log base 5? Yes, you do. Cancel, cancel, and you end up with t is equal to 2/8, which is, of course, 1/4. Let me double check to make sure that this answer is not extraneous. There's my variable. I put 1/4 in here. My log will be positive. You're fine. When it's 0 or negative, you're not fine. You would say empty set. No solution. Okay? Here I have only one log. So what do you do with one log? Think back, think back. That was the first lesson I taught you. Oh my God, that's right. That little snail thingy. Yep, you rotate. So let me go and rotate. 5 to the 0 is equal to 8 minus 3n when you rotate the log. What is 5 to the 0? It is 1 is equal to 8 minus 3n. When you move the 8 over here, you will get negative 7 is equal to negative 3n. And therefore, when you divide by negative 3, you get 7/3. Right? Beautiful. It is positive because of the double negative, right? That's the beautiful thing about math. That in math, double negatives are positive. But in English, they tell you, no double negatives. Here, yeah, they're cool. Alrighty, another log here, number 19. So here, you're going to ask yourself yet again, how many logs? Oh my goodness, there's only one log. And what do you do with one log? You rotate, of course. So let me go rotate. 3 to the 4th is equal to n squared minus 5. What is 3 to the 4th, you ask? Well, it's 81 is equal to n squared minus 5. Okay? So now what do we do? Well, you're going to take away, do the opposite of that. Oh, there's a 4 here that I missed, didn't I? Let's see, let's go back and fix it. 3n minus 5 to the 4th. Oh, my goodness, 3n minus 5 to the 4th power. Okay, sorry. I missed that one. I missed my power of 4 there. I fixed it for you, okay? So now I have 3 to the 4th is equal to parentheses n squared minus 5 to the 4th. What can you notice? That my bases are not the same, but my exponents are. So let me cancel the exponents. So you're left with 3 is equal to n squared minus 5. When you add 5 over to the other side, you get 8 is equal to n squared. And as you know, you take the square root so you can get rid of the square, and you get n is equal to plus or minus 2 radical 2 when you simplify it. Now you're going to be thinking, but Mr. G, you said that logs cannot be negative when I plug them in. But check this out. This is a true answer because when you plug it in for n here, even when you plug in the negative one, what's going to happen when you square a negative? Yes, it's going to turn into a positive, which means that both answers here are legitimate. They are good. So keep it. Number 20. Okay, ask yourself the question, always to begin. One log, you rotate. Lots of logs, you condense. 2 equal logs, what do? You cancel. And here I have 2 equal logs, so I will just simply cancel and get 2y minus 1 is equal to 5y plus 4. And you just solve for y. Let's see, when I bring the 2y this way, you'll get 3y. When you subtract 4, you get negative 5. And so when you divide by 3, you will get y is equal to negative 5/3. A negative. Well, let me go try it. If I get this value here and I plug it into here, you're going to see that a negative minus a negative is going to be a negative, which means that this is not a true answer. It is what we call extraneous, which means you're going to say no solution, or in short, you're going to say the empty set. When you see it, sometimes it'll look like this. It's the empty set. It means no solution. So don't forget with equations, you gotta go back and check your solutions to make sure that they work, okay? Good job. 21. Let's see here. Ask yourself the same question every time. How many logs? 2 logs on the left. What do? We condense. Okay, this is a plus, which means log of 8 parentheses n plus 2 is equal to log of n squared plus 7n plus 10. Whew, barely made it fit, sorry. Now ask yourself again, how many logs? 2 equal logs. Oh, I know that one. We cancel. Voila, there we are. So now I'm just going to distribute and say 8n plus 16 is equal to n squared plus 7n plus 10. This is a quadratic, which means I have to factor at some point. So let me set it equal to 0, which is called standard form, and take everything to the right-hand side, right? 0 is equal to n squared. Minus 8n is minus n. Minus 16 is minus 6. 0 is equal to my two factors. What are my two factors of 6 that give you negative 1? Yep, they're n minus 3 and n plus 2. Because negative 3 and positive 2 give you negative 1, yet when you multiply them, you get negative 6. That means that n is equal to both 3 and negative 2. But this is an equation. Let me plug these both back in there. Yes, when I plug in 3 in here, 3 plus 2 is 5. That one checks out. But when I plug in negative 2 in here, negative 2 minus 2 is 0. This guy is no good. It is extraneous. So therefore, cancel it out. And the only answer is, yep, 3. Okay? Couple more and we are done for this lesson and for the whole chapter, which means we'll be getting ready for the test next week, okay? I have an ln. Oh my goodness gracious. How do I get rid of an ln? Well, Los Nietos kid. How do we get rid of the Los Nietos kid? Yep, you put an Edwards next to him. But remember, it is an exponential, so it has to be written as an exponent. There's my exponential. What's going to happen to these two? They're opposite or inverse operations. They cancel each other out. So now, I am left with e to the 0, which is 1, because anything to the 0 power is always 1, minus 2x. Okay? When you bring the 1 over to the other side here, you're going to end up with 0 is equal to negative 2x. And so when you divide by negative 2, divide by negative 2, you get x is equal to 0. So now you're going to think, Mister, you said x cannot be equal to 0 or negative. No, that's not what I said. I said the logs or ln's cannot be equal to 0 or cannot be negative. So let me go plug it back in here and see if I get a negative. When I plug in 0 in there, this will turn into 0. And 1 minus 0 is 1. So you can see that ln is going to be positive because it's 1. So 0 is, in fact, an answer. And finally, the last one. Here we go. Oh my goodness gracious, more ln's. Yep, that means I need a whole bunch of Los Nietos kids to get rid of all of these. Oh, I have the Los Nietos kids. I got to get some Edwards kids, to just balance the equation here. Okie dokie, so let me remind you that the properties of logs are the same exact properties as if it was the common log, log, or the natural log, ln. So ask yourself, how many logs? 2. Oh my God, 2 logs? You condense. So ln of x over x minus 1, because this is a minus and turns into division, is equal to ln of 3. Okay, ask yourself again, how many logs? 2 equal logs, that's right, cancel, cancel. So x over x minus 1 is equal to 3. Let me make it easier by putting a little 1 here. This is now a proportion. And what do we do with proportions? That's right, sauce. Otherwise known for other students as cross multiply, right? So 3x minus 3 is equal to x when you sauce. And when you solve for x minus x is 2x. When you move the 3, you got that. And when you divide both sides by 2, you'll get x is equal to 3 over 2, which is, of course, positive, and everything will work, right? Wonderful. Well, you have yourselves a wonderful day. Now we're done with this chapter, and so we'll be getting ready for next week's test, okay? I'll be seeing you real soon with a review for the test. For now, this is Mr. G signing out and saying, hasta pronto. See you real soon. Take care and stay safe. Love you. Miss you. Bye-bye.